Hello and welcome. My name is Jacob Kinsey with Cobalt Digital, and I'm the Central US Sales Manager. Today I'll be taking you through our text-to-speech solution, otherwise known as Plus TTS. We'll give a general overview, talk about the physical box and cabling, set up the IP address on a box, look at the watch folders, configure audio routing, take an overview of the features, and lastly, look at the software control panel. We should highlight one of the main differences between EAS or Emergency Alert System and what's known as 21 CVAA. 21 CVAA is the FCC mandate for text-to-speech. That's where you'll find all the information on how to comply. EAS is a mandatory national public warning system that the president or other government officials could use to talk to the general population. The 21 CVAA requirements, on the other hand, involve voluntary information to the local consumers about local needs such as tornadoes, hurricanes, floods, severe weather. These are information that are gathered by private companies and then exported in a key format to the lower third, generally, of a program video. These are different systems, and we will be addressing 21 CVAA compliance, not the EAS system. So the main purpose behind this is for life and property saving information to the blind and visually impaired. So in order to be compliant, all crawl information is played out orally on the SAP channel. That means if you don't have a SAP currently on your program, you need to work with your encoding company to include a SAP program. You also need to have attention-grabbing tones that are played out before the text-to-speech audio is aired on the SAP. And you have to duck in tones over the main program to alert the listener that there's important information coming in on the SAP channel. The information, text-to-speech information, should be covered at least twice in full. The emergency information must supersede all other programming. So if you have a tornado warning that comes in the middle of a severe weather warning, you're going to need a mechanism to break into the tornado warning over the severe weather. Or perhaps you're looking at school closings, you need to be able to break into the severe weather over the school closings. You'll also need to be able to provide a log and playout of all texts for compliance records. And lastly, you'll need to be able to correct for local pronunciations of hard to spell words or pronounce words. The overall workflow is that we'll have a number of different graphics engines, and these could be Weather Central, VizRT, Newsroom Solutions, Stormwarn, and these different graphics engines will publish their key information into various watch folders. Each graphics engine will have its own dedicated watch folder. These watch folders will then give their information to the BBG 1022s, which is the Cobalt Digital solution, and that will then aggregate all the data together and produce a text-to-speech audio that'll be embedded on your SAP channels. For channels 1 and 2, the text-to-speech audio will be put in embedded on one device. And then for your third channel, if you have a third channel, the text-to-speech audio and tones would be transmitted via AES, and also there'll be a GPI connection so that when something is discovered in a watch folder, the GPI trigger will play out to the second unit in order to embed the AES channels into the embedded program of the third channel. So when we have different key information and it's seen by the watch folder, you might have several different storm systems or weather systems or news systems that are putting their key text into these different watch folders. Then we will delete the text once it's been played. However, it's possible that you might have something published to watch folder number 2, which would be in our system's architecture a lower priority. And then you might have something that comes into system or folder 1. Our system will stop the content in folder 2 or pause, and then it'll play out the content in folder 1, and then delete the content in folder 1 and go back to play out what was in folder 2. As far as the physical connections, this is what the box would look like. The unit's self-contained. It fits in a tray on a 1RU rack, and you can fit 3 of these units side by side. It also comes with DC power supplies, and one is primary and the second is redundant, so you have full redundancy. You also have Ethernet connection that you'll need to control and monitor as well as get the files. We also have reference so that you can time and align your signals coming into the unit. GPI is in the form of an RJ45 connector, and this RJ45 connector has a pinout as shown above, where GPI 1 and GPI 2 are pins 1 and 2, GPO 1 and GPO 2 are pins 4 and 5, with 8 being your common ground. The primary channel going into the dual box should go into input D and output A1. This is the relay bypass and will protect in case of loss of power to the rack. This is done through a DIN connector to BNC cable, which you should have. You would need 2 of these, one for the input and one for the output. For your secondary channel, you can use any one of the remaining 3 SDI inputs and any one of the remaining 3 SDI outputs. Again, this would be a DIN to BNC cable. So altogether for both primary and secondary on your dual channel box, you'll need a total of 4 cables. If you have a third channel that you're running AES to from the text-to-speech audio and tones, you'll be using the AES I/O, and this will be a DIN to DIN cable. You'll need 2 of these per box.